In this video, we're going to look at our final method for finding volume in this course. There are other methods, but we're not going to learn them here. And we're going to be looking again at cross sections, although we're not looking at shapes that are being revolved. So in this case, they are not circular in shape. Again, we're still just looking at that cross section, but we have to determine what shape it is. So just like before, we're going to add together the area of each of those cross sections. We multiply it by the very, very thin width. That turns it into volume. So there's not going to be a pie necessarily out here because it's not always a circle. If they are perpendicular to the y-axis, we're going to be adding them in a vertical direction, so we respect y, and I'll show you kind of what that would look like later. So here are some visualizations of what these are going to look like. They're really kind of crazy. I like to think of like different kinds of architecture because they're built on the ground, and even though the earth isn't flat, we can think of these as being built on this like flat surface. So you can see this would kind of be our base shape, and then these squares are popping out of that shape. Okay, so here we're finding the volume of a solid that has this semicircle as its base. So imagine this is on your paper. Well, it is on your paper. And imagine that your shapes are popping out of your paper. So in this case, they're perpendicular to the x-axis and they are squares. And this is what we're really looking for here. So if it helps, you can kind of draw yourself a visualization. Imagine that these are popping out off of your page. And then we have them, of course, all the way across. And obviously they all have different areas, they all have different base lengths. The key thing is we need to figure out what shape we're dealing with, and we're dealing with a square here. So the area of a square is just going to be side squared, so that's what we're going to integrate. Now in this case, our side specifically is going to be the function minus 0. So it may help to even draw one of these out. And this distance from here to here, because it's laying on this shape, is going to be this function, radical 49 minus x squared minus 0, because it's bounded here by the x-axis. And if that's one of my side lengths, I'm going to plug that in right here and integrate side squared. Okay, so if I integrate radical 49 minus x squared, and I square that, this is what gives me side squared. I'm going to add them all together, and I'm adding them in a horizontal direction, so I'm respecting x, and my first one begins here at -7, and my last one begins here at +7. So that's where I'm going to add them together, and I'm respecting x, again, since I'm adding them in this direction. And this is going to give us the volume of that solid. And a lot of these are really nice because we use this radical function a lot, and then when we square that, we're actually really just going to integrate 49 minus x squared. And if they ask you to set this up on the AP test, either one of those are fine. Okay, I think this might be our last example, but again, we have a base region, and we're dealing with cross sections perpendicular to the x-axis again. And this time they are rectangles with their heights half of the side in the xy plane. So here's the xy plane, and we have these rectangles coming up. And the last problem, they were squares, so we knew their height and their base were the same. In this case, they are rectangles. And I'm just going to take this rectangle here, and I'm drawing it out bigger, kind of flat. The base length is always my function minus my bottom function. So in this case, it's going to be -x squared plus 4 minus 0. And then it says the height here is half of this side in the xy plane. So half of whatever we have on the graph. And now, since we're dealing with a rectangle, the area of that rectangle is going to be length times width, or 1/2 -x squared plus 4 times my length, which is -x squared plus 4. And my first rectangle is going to be here, and I'm adding these rectangles in a horizontal direction. So again, I'm respecting x. My first one occurs at -2, my last one occurs at +2, And this is how I would set this problem. And that's it.